Top of the afternoon to you, ladies and gentlemen. A very warm welcome to all of you to this webinar on next generation design for consumer products. This webinar is titled Adopt the Digital Twin for Consumer Products. We are going to do this webinar with Siemens Digital Industries software. So before we begin with the presentation and the questions and answers on this topic, let me introduce very quickly the topic to you and our eminent speaker for today. Consumer products that companies make face many unique challenges. Today's devices feature rapidly increasing electrical and software content. Resolving highly complex issues impacting multiple disciplines is increasingly critical to product availability schedules. Annual product refresh cycles demand high levels of reuse among core modules, rapid styling updates, and the need to simulate and validate completely new designs on critically short timelines. Automation tools, stunning visualization, and the ability to reliably feed manufacturing systems are critical. They need to respond directly to consumer experiences, which dramatically increases the influence of their sales and marketing teams in the design and manufacturing process. In this session, you will find out how you can increase your agility, accelerate your ability to meet increasingly demanding schedules while increasing quality and reducing business risk by adopting a digital twin strategy. All of you must know what a digital twin is, but I will reiterate it for you. A digital twin is a virtual representation of an object or system that spans its life cycle, is updated from real-time data, and uses simulation, machine learning, and reasoning to help decision-making. The flow of this session will be as follows. Firstly, with the presentation, you will see industry trends from the speaker, who I'm going to introduce you to in a bit. Then we'll have, after industry trends, we'll have the problems. We'll have what is the digital twin and what is it, what entails in adoption of the digital twin, followed by a question and answer session. The speaker that we have today is Avinash Gangaiah, whose portfolio development, product engineering solutions, Siemens Digital Industries software. Avinash is an experienced technical consultant with over 10 years of experience and has helped customers deploy and use digitalization solutions in the area of product development and manufacturing in the automotive, defense, heavy equipment, and industry machinery segments. With his experience of using digitalization technologies to streamline processes, he possesses an in-depth insight on these technologies and their applications for supporting a variety of organizational goals. In his current role, Avinash is responsible for advocating and driving the development of product engineering solutions portfolio through the identification of a clear target market and go-to-market strategy, and the execution of campaign-centered strategies to leverage and maximize portfolio adoption. The company portfolio ignites digital transformation, and I'm talking about Siemens Digital Industries software. This company has a portfolio that ignites digital transformation, empowers companies of all sizes to embrace complexity and leverage it to enhance productivity and gain a competitive advantage. Thank you once again, attendees, for joining us. I'm handing over the session to Avinash to deliver his presentation. Avinash, over to you.
Thank you, Anandji, and a wonderful good afternoon to each one of you on the call out there. So thank you for your time and thanks for joining in. I hope you're all able to see my screen okay. So with that, let's get started in terms of, what we're talking and looking at in terms of the industry trends that are there in the consumer product space, and also in terms of the problems that industry as such is facing in general, and how do we look at addressing these problems in terms of what can we look at in terms of improvising our existing deployment of solutions and capabilities that we're looking at, and also in terms of adopting the new age technologies also to go ahead and then how do we improvise on our existing markets, right? So with that, let's get started. And like I said, so we'll start about looking at in the industry trends itself. So what is happening in the industry itself in terms of the trends. One is, a lot of personalization keeps happening, and these personalizations are all mostly driven by customer requirements, right? And that said, which also means that you may need to have a lot of connected products, maybe as simple as probably a watch, right? So how do you go ahead and then add those customer requirements? How do you address them? And when you say more and more connected products, you also mean that you may need to add a lot of smartness to your product in terms of wiring harness, in terms of software. But at the same time, you may also need to look at how do you have an efficient market introduction, because it is also looking at bringing in a lot of competition globally as well. You may need to expand to other geographies, but some other player who's already established in a different geography may want to walk into a different market to try and see how we can capture it. So how do we look at addressing these industry trends is very important, right? So, but this also brings in a different or a unique problem in itself. So what exactly? So when we say in terms of personalization happening and a lot of connected products coming in to the picture, so what happens to your existing product portfolio? How what are all the challenges that you need to if you say, okay, from tomorrow onwards, let me go ahead and then start addressing these industry trends. So when you take that path, what would be the set of hurdles or challenges that you may face? You may have to look at a lot of complexities coming in terms of how do you have an integrated portfolio, integrated teams working together. You may have different teams working on mechanical side. There may be a different team working on simulation or testing the strength of the strength of the product itself. Some of the team working in silos, right? Most of the teams working in different geographies or maybe in silos. And how do you ensure when you have to try and address those industry trends, you can see a lot of complexities popping up in terms of as and when you're trying to make it as good as possible, right? You also need to ensure that you're not you just have to be as cost effective as possible. How do you go ahead and then make it addressable to a global market? How do you get rid of the competition itself, right? So now the point here is, while we were able to look at the trends, and then we see that, okay, when we have to achieve the trend, there are these complexities that are coming, right? So if this is what I'm trying to, if this is what I have to address in order to achieve my ideal state, right, in terms of my product market, right, what can I do? I see a lot of complexities, right? But the whole goal here is to try and see whether it is possible to go ahead and then take advantage of this complexity itself. So how can I use complexity itself as a competitive advantage in order to leverage leverage the current situation and then be able to take on the competition in a better way, right? So what is it that I can do to go ahead and then achieve or take advantage of this complexity itself, right? So there are three ways of looking at it. One is looking at you did hear Mr. Anand talk about digital twin. The whole goal is to look at how can I achieve, as an organization, achieve a comprehensive digital twin. When I say digital twin, I'll talk about it in depth also in the coming slides, but the whole goal is to try and see how we can mimic digitally the behavior of your product right from the time it's being conceptualized till the time it is manufactured and being put to use by its end user, so that throughout the cycle you are able to mimic its behavior and then be able to gather an understanding of the product so as to have enough information to make the product better in the next generation. In terms of, let's say I have first generation product released, and then based on the information that I've received, I'm able to make a better set of products in the next generation that I'm trying to build, right? So that's the whole goal. But at the same time, digital twin also will help you to digitally validate the product itself without even the need to build a prototype, without even the need to not just building a prototype, but also think of the time that's involved in building a prototype. That also think of all the costs that get involved in building a prototype and all that. But how can you achieve the entire product development in a digital thread via a comprehensive digital twin? That's where Siemens's accelerator portfolio comes into play, where if you look at it, let me turn on the pointer here. So if you look at building a digital twin, so what all we would need, right? It's not just a product development. It's not just a CAD modeling platform. It should be to where, in terms of building the product itself, and then how are you able to collaborate in terms of all the data that you're producing, in terms of all the software that are coming in into the product, in terms of, as simple as the watch itself that I gave the example in the beginning, all the IoT and analytics in terms of, if you have a shop floor, how do you look at having a smart manufacturing in place, or if you have a product itself, how are you looking at a smart connected product approach in place, right? Also in terms of the manufacturing operations itself, how are you able to monitor what's happening on the shop floor, just to ensure no machines are left idle, or you're not seeing any unexpected downtimes in place. And then also be able to, whatever product that we're developing or producing, uh, I'm able to validate it digitally well early in the cycle itself, so that I'm confident as a producer, I'm confident that my product is going to behave the way it is expected to be, right? And we are talking about everything becoming smart, and it can only become more and more smart with a lot of electronics and software going into it. So how do you address all that? That's where the accelerator portfolio comes in. And today we are also talking about how, from a mechanical standpoint, how we are able to address the entire product development itself in terms of conceptualizing or industrial design and styling till the time it is being manufactured. So I'll go in depth onto it, but the whole goal here is to try and understand how the accelerator portfolio will help you from an end-to-end product development standpoint. So let's look at a digital twin. Like I said, it's not just a representation of the CAD model alone. It's also the representation of being able to validate how it is created, how it is produced, and how it's going to perform as well, right? So here we're talking about building the product digitally, but at the same time, how it is being produced, and then how it's going to perform, right? So that's the whole goal, and that's where we're looking at building a holistic digital twin or a comprehensive digital twin, right? So now, just a quick summary of in terms of where we started. We started off with the industry trends, right? We said, okay, these are all the industry trends that are there, right? So considering that to be an ideal scenario, or where any organization would try to look at or would try to address that, then we realized, okay, if an organization says, okay, let me go ahead and then address these industry trends, right? You'd see a certain number of challenges or complexity explosion happening, right? So those are the complexity explosions we were able to see. And then one step ahead, we could see that, how can you look at, is there a possibility to, leverage these complexities to your advantage, correct? So how do we do that? With the help of a comprehensive digital twin. So what would be the ways and means in which we can look at it, right? So that's where the the next generation design from Siemens' accelerator portfolio will come into play for consumer products in terms of in terms of your industrial design and styling and model based definition and all that. We'll talk about the digital twin in depth, in detail. But if you have to look at your own product development, if you want to go back to the drawing desk and then try and look at it, okay, how can I look at, if I have to achieve a digital twin, where do I start, right? So let me point out about 6 pillars here, which will help us to look at our product development in each of these 6 pillars itself. And then we can pick and choose any of these pillars and then start working there to achieve the digital twin. Ideally each of these 6 pillars will give us a potential to achieve or improvise on a product development itself. So the very first itself is improvising your existing product modeling environment itself. So I'll talk about it in depth, but where the whole goal is here is that Siemens's product modeling environment, that's NX. Over the last couple of years, we've invested close to $100 million in the product development itself. And as a testimony to that, our team has also won awards in the AI Connects Awards, that is the Artificial Intelligence Connects Awards, which also means that when for example, when a user is trying to go through a certain workflow process, say for example, a sheet metal building, or for example, something on industrial design and styling. He wants to build something on surfacing, right? There is a set of commands that he will use, right? As an engineer, right? But the software will be able to predict and understand what would be the set of commands that the user would use more often than not. And then based on that, it is able to predict the next set of commands that you would need, right? So basically, one is helping you to put a sanity check in terms of the design development process that is happening. And then let's say in your position, let's say a new engineer who's joining in, he's able to, he will be guided based on the same set of predict command features that will come in. So he knows what are the set of commands that he can probably look at using to achieve the right modeling methodology itself, right? So that is one example. And the other one also is that I'm talking about is the generative design itself. Let's say, you would have a standard design in place. Depending on the fit and finish, you may not be able to change much, but is there still any kind of room to improvise on your design? That's where, the generative engineering comes into play, where you can say that, depending on the size, depending on the, input conditions, go ahead and then, you tell the software to, leverage engineering tools to improvise on the product itself. I'll talk about that in detail. But then if you have to look at your own, product modeling environment, again, how much are we using it for additive manufacturing? And if you also see it clearly, I'm talking about industrialized additive manufacturing, meaning I'm talking about 3D printing in production, right? We'll see that in detail. And then again, I spoke about, more and more products getting smarter. So what do we mean by smarter? It also means that a lot of wiring, electronics going into the products that we're making, right? So that's one way of looking at things becoming more and more smarter. But how do you get the space analysis done? How do you ensure both the teams, your electrical CAD team and then, mechanical CAD team, are able to talk to each other well? And then how is that seamless integration happening also is very important. And talking about any organization, when you're also building the product of the future, right, consumer product, right, it is very important to involve all the stakeholders very early in the cycle, in terms of workflow, in terms of your vendors, in terms of your customers and suppliers. How do you share the data so that they are able to have access to the right information at the right time, right? So that's again very important to understand. And with all this being done, we should also have the confidence that, whatever that we have done, we are able to validate that, and then ensure that we should have the confidence that the product that I am about to roll out will behave as expected. So for which, if I as an organization need to run some analysis and tests, how do I do it digitally and quickly, right? So on the same product modeling environment itself. That's where an integrated, not just a siloed environment, but a very important is to have an integrated environment for your simulation and manufacturing as well. So let's look at this in detail, right? So I spoke about the most productive modeling environment. I spoke about the investments that we're making, and then one testimony or example of, how we won the award in the iconic space itself, right? So with that, if you're also looking at industrial design and styling, more often than not, you will have your industrial designer quickly get a sketch and then, give you a shape and design and say, okay, this is something that we can work out. This can be a new product concept and all that, right? But what also happens is, if you want to look at it and doing a detailed design standpoint, right? So you'll still have to do it in a 3D model, right? Not just a 2D SketchUp, correct? So that's where having the ability to reuse whatever the industrial design team has already given, be it a 2D SketchUp that is there, you can quickly use those images being imported on the environment, into the environment, and then leverage the same to go ahead and then, build the concept quicker, so that you are able to quickly make decisions faster, right? At any point in time, you can see the ease with which this is basically, we're talking about subdivisional modeling, where you can quickly have more and more control points, add as many control points as you need, and then you don't have to worry about, whether I'll be able to bring in the images or not. You can see the ease with which you can bring in these concept images, and then using that, you can go ahead and then ask your industrial design team, who don't have to worry about what commands are there, because it's as simple as drag and drop that is there, right? So again, the goal is to be able to help you to build your concepts faster. And then sometimes, what also happens is, you will still have people giving you data in different file formats, right? So uh, what if your team has to, in the end needs to make some edits to that data that you are receiving from your customer or vendor or supplier, whoever it is, right? So at that point in time, you don't need to depend, or you don't have to, go back to your the respective stakeholders for requesting those changes. The idea is to, you're in a platform where you can go ahead and make those edits at any point in time, and then you can see the ease with which you can do that. You don't have to worry about whether you have the entire history tree of the way in which the product was built. You don't have to worry about that, because using Siemens's synchronous technology, you can go ahead and then make edits on the geometry directly, right? So you don't have to worry about the source data. That's the whole goal here. And not just the multicad file format. Just imagine if you also have your own data, but at any point in time during a last minute stage change, if your late stage design changes come in, you may want to make some quick edits before your design release happens. You can always leverage this concept as well, using direct editing to go ahead and then, make edits to the data as well. So saving you, that much important time as well for your, overall design and development cycle also, right? And what also happens is, imagine you might have some old products for which you as a user, you as an organization will not have the actual CAD models for the same. And what if you need to make some changes to it quickly, right? Or what if you have some mesh data coming in? You would have done some kind of scanning. You may need to, leverage that to quickly bring them in, and then, make edits, and then start using it in your product development environment. Now, what usually happens is, you would have seen a lot of engineers spend a lot of time, because they'll have to convert the imported mesh data or 3D scan data to go ahead and then make it into a solid first or a surface first, and then be able to make it into convert it into a solid, and then make until it is really editable or reusable. This in itself is a big challenge, right? And what we are saying is, with convergent modeling, you can use surface data, you can use your solid data, and you can also use your facet data, which and all three in one single file format, in a convergent modeling technology, wherein you don't have to wait to convert your mesh data or 3D scan data into a solid. You can directly use them for all your Boolean operations, right? So imagine the amount of time saving that the product development team will be able to gain out of this, right? So that's the benefit you'll get in terms of the convergent modeling itself. So if you have to put a couple of pointers from the most product modeling and most productive modeling environment also, right? So you can look at, how do you go ahead and then increase your engineering team's throughput, and also take care of the quality itself, and eliminate all the silo tools that will be, working in different environment. The goal is to leverage synchronous technology to be able to make your engineering team work on any data irrespective of the source itself, right? And then I said I'll talk about the generative design in depth. So let's say you have a standard you have a standard design that is there, on which, because your products are getting more and more smarter, you'll still have to look for ways and means where you can still, because your products are getting smarter, you need to add a lot of you may need to end up adding a lot of electronics to it. You may end up adding a lot of harness to it and all that, right? But when you try to do that, right, you also realize that a lot of weight is going into it, right? So which means that you can't, while you want to make your product smarter, you still need to take care that the weight is not going beyond a certain limit. So how do you compensate on that? So there are a couple of ways of doing it, and one of the ways is to go back to your original design that is already there, look at it, and then say, how do I improvise on that, right? So one of them is where you take a standard design and then go ahead and then say that, okay, these are my input load conditions, these are my fit and finish, this is where this is where that particular component will fit in, and then you let the technology take care of the calculation piece, where it will run number of iterations to come back to you with a final iterated model, to give you design data that will meet your need in terms of, let's say, one of your goal is to reduce the mass, right? So while the strength is not compromised and the goal is met, uh, everything done on by just leveraging the power of your computer, you can do that, right? So that's the goal that we're talking about in terms of, you can run multiple iterations here. Let's say, for example, if you're looking at the concept of an example of the printer here, right? So all we're doing is we're just leveraging the power of the computer here, right? So and then you can see here, based on the regular flow or regular design, you can see maximum load, stresses, everything's here. So what can we do to improvise on that, but yet at the same time we can increase the flow there better, right? So this, it's not too hot here, right? So just a simple example. So based on that, based on the flow, you're able to quickly go ahead and optimize your design itself. One is that will help you to reduce the mass, that will help you to have a better workflow itself, have a better, how do I say, better product design itself in place. So you can see a clear comparison here. On the left hand side, you are seeing the original design, and on the right hand side, you are seeing the optimized design. So there's a clear visual indication of how the design has changed, and then giving you a clear visibility of the flow as well. So you can see the way in which, if by looking at, you're able to improve or optimize the mass flow by about 22%, right? So the whole goal is to leverage the technology, let the let the power of your computer and the technology you know take things forward to help you to design your products better, right? And then one other thing is also, if you're looking at lightweighting your product, right? So if you're looking at, how do I go ahead and then use existing technologies or new age technologies, one of the new age technologies is additive manufacturing, and that being used in production, right? So you can see the you can see one dashboard command that will help you to quickly help the engineers to quickly pick and choose the area in which they need to go ahead and then add lattice structures, or probably most commonly also most common used lattice structure is basically a honeycomb structure. You can see, you based on the region that is chosen, you can go ahead and then get a neat dashboard that will help you to define the way you need those lattices to be placed. You can define, you will have more control in terms of the unit sizes, what kind of lattices you need, what changes do you need. You can also ensure it is taken care, it is printable. You can do all your print checks as well, right? So um, giving you that much flexibility in terms of optimizing your design, right? So that's what we're talking about in terms of your overall existing design development process itself, right? So we're talking about personalizing your design. Wherever you need to make those changes, you can always go ahead and then do that. Let's say you don't want to look at it in terms of the topology optimization, but you might want to look at it in terms of, how do is it possible for me to add some lattice structures in my existing product itself, right? So uh, it will help you reduce your tooling costs as well, right? So overall part count, you can think of it, and I'll just give you just two simple metrics that you can look at. If you're able to reduce your tooling costs, and if you're on volume production, think about the amount of money it's going to help save you, right? Number two is as part of the mass reduction, right? So even if you can reduce 1% of the mass of the component, think about the overall assembly, and if it's in volume, you can do the math on your own. That will give you a very good number in terms of the amount of money saved, as well as the amount of mass that you are able to save based on the mass that you are able to save, right? So that's the benefit you can leverage in terms of generative design and additive manufacturing also. Right, then things are getting more and more smarter, right? So with that, we're talking about I said a lot of electronics will go into it, or a lot of wiring and harness, a lot of ECAD will come into play, right? So traditionally, a lot of these teams usually still even now, a lot of these teams still work in a lot of silos, right? So if you want to have your mechanical team work in tandem with the electrical team, so that they are able to communicate together well in terms of where do I place, let's say there's an area where I need to place my ECAD component, maybe a resistor, or maybe I need to place some kind of a, mechanical CAD component. How do they talk to each other? Let's say if there's an ECAD component that is basically generating a lot of heat, how will the mechanical guy quickly be able to make some place to add in some kind of vents so that it is able to have the cooling effect in place, right? So as simple as that, I'm just giving a couple of examples, but how are they able to talk to each other, right? So having a seamless electromechanical CAD platform where both your teams are able to talk to each other in a seamless way is very, very important. And NX enables that, even in terms of the way you're able to exchange your PCB data is also something that we are able to address that as well. So you just saw a simple example of that, right? So having one of the key is a key aspect is to ensure that both your teams, especially the mechanical and electrical teams, are able to talk to each other very, very seamlessly. That is very important, especially when we're looking at in terms of having our products becoming more and more smarter, right? And the important metric that you'll also see that will improve when you're able to deploy digital twin like this, especially in the electromechanical domain, is getting rid of all the last minute surprises that will come in, right? So that is very important to ensure, I don't want to be hit by any kind of last minute surprise that will probably push my overall release cycle by about a month or two, right? So that's the whole goal, so that everybody is well aware in terms of what they would like to do, uh, how each of these domains or teams are gonna work by talking to each other seamlessly very early in the cycle, right? And also in terms of we're talking about a lot of teams working, and then how do you collaborate in terms of how do you share the data to an existing stakeholder outside? How do you share the workflow data in terms of a workflow itself, right? So how do you use it for some kind of an audit log? How do you use the overall workflow process in terms of the versions, in terms of the change management in place? So you can see everything within the NX or product modeling environment. You can see a proper workflow that is configured, and you're able to access that within the NX modeling environment itself, helping the user to be on the same single platform, but yet at the same time be able to quickly work around to understand what are the requirements that are there. Based on the requirement, how do I collaborate with the right team, with the right stakeholders to go ahead and then get my work started, right? So the goal always here is to be able to ensure you're able to provide right access to the right stakeholders at the right time, right? So that's the whole goal here. Here you can see the quick concept share data that is being shared in terms of what needs to be changed, where the idea is coming from which team it is being shared, what needs to be captured. These are the requirements that are coming in, and based on that, how do you quickly use that information as a reference item to go ahead and then start building your detailed design as well. And then you should also be able to share whatever data that you built. You should also be able to share it in probably the most common format is a 3D PDF, but how do you share it in a templatized way of the same itself? That's where the technical data package comes into play, where you can share it to the right stakeholders outside your organization also, without compromising on your IP, right? So that's the whole goal. And then if you're also looking at these the components, that the products that we're releasing, we should also be able to communicate in the right way, where we can showcase the way the component or the product will work, right? In this case, you're able to show the animation of that. And imagine your customer or your vendor or your supplier is in a different location, right? So imagine because of the pandemic, right, we could not ship out a lot of these products outside, and then there are a lot of curfews, travel restrictions, and all of them coming in, right? But how do you communicate that in real time in a 1:1 scale? That's where an out of the box virtual reality comes in. And within NX, without the need to prepare your data, which means that you don't have to create a lightweight format of the data, an out of the box an out of the box capability within NX will help you to, with just one click command, you can put a variable, and then you can share the data to your suppliers outside the organization or your stakeholders, maybe in a different geography. All three or four of them can communicate together real time on the same data, while staying in three or four different places in real time. That's where we are comes into play, and then plays a very vital role, especially during decision making or design reviews, right? Dynamic design reviews if you want to make. And imagine the benefit it will give when you are able to see it in a 1:1 scale, right? So that's the whole goal. And then one very important aspect is whatever we design, we usually take the same data outside to, for using again a siloed approach for building rendering, right? So you can see the images that you are seeing here are all built and rendered well inside NX itself. So you can see the richness, the lighting, the richness in terms of the data, the image that you're seeing, all of them, even on the animation itself, you can build it right within NX itself. So the goal here is that, again, I'm just reiterating the same fact, from concept till the time it is manufactured, each part of the product development process is something that you can capture here, right? Also in terms of the animation, I spoke about it, right? Even when you have animation, you can have a rendered image for your animation, right? So it's not just a static image, you can use it for your rendering as well, right? So that's what I was talking about. Coming to the last topic where we are talking about an integrated simulation manufacturing, where we're saying, if I'm able to understand, based on the analysis that I'm doing, if I'm able to understand what are the forces that get generated, it can be a dynamic force, it can be a static, it can be any force, right? So based on that, can I quickly make any kind of, validation about how the product or the component would behave, right? If there are any concerns, can I make any edits to it very early in the cycle, rather than once I build a prototype, which of course will take certain time, and then I do a testing, and then prototype will take time and cost. You do an iteration, go through the same cycle again, come back. Rather than that, is it possible for me to be on the same platform, on my product development platform, but yet at the same time be able to validate if the product is behaving as expected? Are there any kind of design challenges, or in terms of structural integrity, if I want to test the flow, or right, any of those things, right? So how can I do that? You can see here in this case, I can quickly go ahead and then understand what are the generated forces. Even if they are reaction forces, I can understand, gain at what point in time, gain information, insight into what point in time, what forces were generated. I can get the information that I need to run my analysis as well. So you can see a clear indication of how you can use the same analysis for, generating the data you need to go ahead and then, do your simulation as well, right? So that was one case. And the other case is where we're talking about how do you quickly use it for, let's say you want to do flow analysis, right? So based on that, how do you go ahead and then quickly make any edits to the data? Even before you do that, will you have the right information in terms of how the flow is there? In this case, based on the vents that are there, I know the kind of flow that is coming in. Is it good enough for the product or not? Based on the design requirements, I'll be able to make the right judgment call. But all this again in a digital environment, right? So the goal here is, if that is where the handle, the end user is going to hold that, right? So is the temperature too high? If it is too high, can I add one more set of vents there? Is it possible, right? What is the impact of it, right? So all those things is something that you'll be able to do, and everything in a comprehensive digital twin. So that's the whole goal that we're talking about, right? And then we'll have products where we mean talking about manufacturing. You may also need to be able to quickly build the right infrastructure that you need from the tooling standpoint also, right? So if you want to build the core, the cavity, if you want to do any kind of quality check that you need, if you want to do mold, right? So staying within the NX environment allows you to maintain the associativity to the original design, but yet at the same time, referencing that design, the organization will be able to go ahead and then build the right manufacturing suit that you need. In terms of, in this case, we're talking about mold, and you can see how mold wizard would guide the user in terms of the right process flow that one would need in terms of going ahead and then getting the right information in place, right? So that's the whole goal that we're talking about here, right? So let me turn off the pointer. Okay, that's good enough. And yeah, right. So that's the whole idea that we're talking about in terms of manufacturing, whatever we need, right? So if I want to have some kind of set of surfaces in place, anything that I need for my mold, all of them are covered. And then you can see a mold wizard that will guide the user from, in this case, we're talking about parting line, parting surface and all that. So it will guide the user in terms of everything that he needs as a step-by-step procedure, so that he can go ahead and then start building the right necessary information to get started. Imagine, even if you are a supplier to an OEM, in that case also this will be useful. Or if you also have your own in-house team as well, that's going to work on this information, again it's very useful to have an end-to-end workflow in this case, right? So not just designing the core and cavity, but if it's also about building the mold base itself, how do you go ahead and then do that? So the entire extension is part of the overall end-to-end product development workflow that we're talking about, right? So again, ensuring you're able to validate manufacturability, the performance of all these products even before they're physically produced is very, very important. Having a closed loop cycle is important in terms of trying to understand whether everything's taken care or not, right? So with all these things you're able to do digitally, you're able to save a lot of time in terms of the time it would take for you to build a prototype, so that you can hit the market faster than your competition. And again, while doing everything with the help of a digital twin, you're also saving a lot of money in terms of the cost that will be incurred with a lot of prototypes coming in, again helping you on your margins so that you can pass on the benefits to your own customers, right? So that's the whole idea. So let me quickly summarize. We spoke about how the most productive modeling environment will play a vital role in terms of looking at your regular day-to-day workflows. We spoke about our ongoing commitment to produce the best-in-class tools, generative design. Just by using the power of your computer, you can do that. How do you build the next generation product component? I spoke about using additive manufacturing or 3D printing for your production usage, taking your design to the next level. Having a seamless electromechanical design platform is very, very important in terms of achieving or getting rid of any kind of last minute surprises. Being able to share the data involving all the right stakeholders at the right time with the right information is again vital, and that's where NX comes into play. And in the end, whatever that we've developed, we should also be able to validate the design in terms of running all kinds of analysis that we need to ensure it will behave as expected and then is manufacturable as well, right? So that is what we were covering in terms of the digital twin. And then if you also look at an entire comprehensive digital twin, you can look at digital twin from an organization standpoint also, in terms of the whatever that you are seeing on the left hand side at the top is where you be looking at building the digital twin itself, in terms of getting the concepts in place, in terms of doing all the R&D, in terms of validating them, in terms of trying to understand how it is going to get manufactured, right? So in terms of what needs to be done, what's the bill of material and all that, and from there it starts flowing onto the machines where if it is in-house, the team will start leveraging the same information, will go ahead and then start manufacturing them, go through the performance I spoke about, right? Not just designing the product, um, you should also be able to capture the information in terms of, or define the information in terms of how it will behave on the product itself, right? So in the real world, so you can capture that as well. So that's where a comprehensive digital twin will come into play. Now the question that will come from your end is, okay, if this looks good, what do I need, or how does it work, right? So if your first question is how does it work, it's based on different business models, in terms of you can start working on an X or a product modeling environment as a perpetual license or a subscription license. It can be deployed on site as well as cloud, or even in a hybrid mode as well. But then the last slide that I just want to bring in is where the adoption itself and how we are making it easier for organizations both small and big in terms of making the adoption easier is by providing flexibility in terms of licensing itself. Let's say you would have based you would have spoken to a lot of software companies that would be working on the product modeling environment, and every time you feel that as an organization you need to do something you would want to probably use a technology, let's say additive manufacturing, or let's say advanced assemblies, or let's say you'd want to use a capability that is considered a high-end technology, but when you want to do that you're told by your existing technology vendors that yes, this is absolutely available, but you'll have to buy an add-on license, right? And that is a common scenario everywhere, right? And but you as an organization, one is you might still be testing it out first, and second is it may not be used every day, right? It may be used once in a week or maybe 5 or 10 times in a year, but it is important, it does serve value, it does bring in a lot of value and does make a difference, but you may not use it every day, right? So that's where a flexible licensing capability is also very important to ensure a smoother adoption. So let me show you and run you through this slide. Do not worry about what is shown at the top, but let's concentrate on the bottom part of the slide. Let's say your engineering team, about 5 of them, start with base capabilities of NX, and then you start with about 100 tokens, right? And at 9:30 in the morning, one of your engineer wants to do something on human modeling. Maybe he wants to get some ergonomic design, everything in place, right? So when he launches that license, right, so you don't have to buy a particular module. Instead of buying a specific human modeling module, it just consumes 26 tokens. Okay, based on, so every module will have certain set of tokens. Human modeling will consume 26 tokens. So out of 100, you are left with 74. 26 is consumed, right? So what happens is, let's say at 9:45, another engineer wants to do something on aesthetic design in terms of getting a right styling in place and all those things, right? Again, that consumes a certain number of tokens. So 74 minus 35 are left with 39. But what happens is, at 10:15, your engineer, the first one who started off or launched a particular module, in this case human modeling, has completed his work, and once he's done that, he's going to shut this license down. This particular module or 26 tokens will go back into your pool. 26 plus 39, you're looking at 65 tokens again, right? At 10:30, somebody wants to start doing something on routing. You may wants to do some kind of wiring on this, or maybe the mobile phone or anything, right? So at that point in time, again, this will consume about 25 tokens. So 65 minus 25, you're at 40. But at the end of the day, imagine everybody shut the license down, go home, and then come back to office on day 2 when you're starting at 9 a.m. again. Not only do you start with your base licenses of Mac 1, 5 seats, but you're also starting with the same set of 100 tokens. So meaning, whatever tokens you used on day 1 are not, will not get exhausted. It just gets locked. And then once you release that particular license, it will go back. Now let's go back onto the actual number of licenses that you can access as part of it. You're looking at close to 60 plus add-on modules that you can access on top of this base license, and then use it whenever you want in production. So from a consumer product standpoint, what all would be beneficial, right? So you can look at in terms of the routing and cabling that you can all do, and also in terms of all the industrial styling that will be made available as part of the flexible licensing through realized shape, appearance management, render. You saw about the render capability that we showed, right? And also in terms of tooling and fixture, the mold wizard that you saw, you can also check one-step formability analysis and all that. Any kind of translator, if you want to work with folks giving you different kind of data. And the core mechanical design environment here is where we're talking about advanced sheet metal, if you want to do convergent modeling, human modeling in place, right? If you're also looking at weld assistant, assembly path planning, which HT 3D rich visual reporting, if you want to quickly bring up visual report in terms of give me all the components with XYZ material, give me all the components from a different vendor. You can do all of them, right? And you can also get the animation designer. You spoke of, you saw the way in which I was able to show the product behavior, right? So you can use animation designer to show the product behavior in terms of assembling, disassembling, right? So all of them, you can use that for your animation designer, structure designer in place, algorithmic modeling, additive manufacturing, all of them. Most of them is something that you can access as part of your flexible licensing, right? So imagine the amount of benefit that you can get in terms of as against compared to buying one single license alone and then stuck with it for the whole year, and you still have to pay for the actual price of that for an entire year. Compare that to having access to about 60 plus add-on modules with the help of certain number of tokens, giving you the flexibility to use whatever that you would want, that you feel would add value for your design team. And that's where the value-based licensing concept from NX comes into play. So with that, I just wanted to close this with one or two customer examples. In this case, we're talking about Polar, where they wanted to look at the balanced size, weight, and ergonomics functionality as well. So the goal here is to, where they leveraged the NX platform that we spoke about in terms of all the benefits that we saw in terms of, you can see they were able to increase on the performance, but lower the cost itself, right? So while we are focusing on increasing the performance, I said it in the beginning itself, so not compromising on the cost or the margin, right? So how do we take care of that? So that's where a comprehensive digital twin will come into play and play a very vital role there. So with that, I'm open to question and answer.
Wow, what a fascinating presentation, Avinash. That was really informative. It touched upon all the points, all the aspects that practitioner and a potential user of the technology would want to know. And it brought to mind so many questions to me, and I hope it did the same to for the attendees as well. I request all the attendees to start sharing your questions, and I have so many of my own, Avinash. I will start by asking a question on a point that you rounded up the presentation with, which is about adoption. Now, uh, and this is about industry adoption in general in for India.
Yeah.
So, from your experience and observation and the vantage point that you have, at what stage is the adoption for digital twin in India is? Is it at an early adopter or an early majority stage? Where do you see it right now in terms of the industry segments as well? Is it there for highly complex products like those of aerospace and automotive, or there are other manufacturers also open to using it? Avinash?
Yeah, first of all, a wonderful question, and happy to answer that. So the point here is, the adoption of digital twin itself is that I will not be able to point a particular stage, but in every industry, you can see a lot of organizations who are early adopters, right? So they are open to the challenge, they are open to exploring it, and then they've been able to see a lot of benefits in it. And if the digital twin adoption is not done right at that point in time, and of course there can be failures as well, right? So that is where associating or leveraging the help of the right organization to help you in the adoption of digital twin is also very, very important. And if you ask me personally, I think from product development standpoint, the digital twin is very vital for almost all industries, be it in industrial machinery or aerospace and consumer products, and any of these industries that you take. Digital twin is very, very important because the even if you're looking at it in consumer products, you're looking at it at volume, right? Let's say even if you're able to commit a very single mistake, think about the cost that you'll incur as part of the losses, right? So but look at it on the positive side. Leveraging digital twin, even if you're able to save 1% on the product, right? That's why I give the example where you said if you can reduce the mass by about 1% in one single component, and then you can extrapolate it to an entire assembly that you're talking about, entire product, and think of that in volume production. So that itself will give you a number. So if you ask me, I think there are early adopters, there are organizations who do a lot of catch up, and there are laggards as well. But the whole idea here is in terms of taking the right path to the digital twin is very, very important. And that's why I said, if you also looked at my slide, right? So you can start with any of those 6 pillars. You may feel that my product modeling is good, I may want to look at digitalizing in terms of generative design, or I may want to look at using additive manufacturing. So because digital twin is probably most commonly used word, right? So you would have heard a lot of folks using, but the goal is, where do you start, right? So that's where you need to get the right guidance in terms of where you can start, what you can leverage, and associating with the right organization to help you in adopting the digital twin is very important. And that's where Siemens plays a very vital role there.
Thanks so much, Avinash. The next question that occurs to me, and I've been wanting to ask this for a long time, is that digital twin is a very important piece of the whole industry 4.0 picture, very important piece. And I remember an expert saying in one of these forums that, India missed the original industrial revolution bus. And it is the digitalization of manufacturing that is going to help India get back onto this revolution and to this way. Now, in digital twin, I see that it has the potential to solve a number of problems that our manufacturing industry faces, namely high cost of infrastructure, high cost of logistics, lack of innovation, the problem of decision making in terms of the quality of skills, the product quality, for instance, and yes, and the biggest problem that we have is lack of robust ecosystem for MSMEs. See, as you know, Avinash, that the presence of strong MSME sector is the hallmark of a very robust manufacturing ecosystem. In India, our industry is highly fragmented. A large part of it is unorganized and comprises MSMEs that are not able to scale up. So I have given you a whole host of issues that we are facing. And among these, what would you pick as the topmost challenge? Because I'm so excited about this technology in the way that you've presented different facets of it. What are these different challenges that this technology in particular would be able to address? Avinash?
Yeah, so first of all, thank you very much for the question. And I'm not, I'm happy to address this. I think I'm having this kind of a conversation on more or less same lines with, for probably the third time over the last 10 days. So I think this is happy to answer that there. So if you ask me in terms of, how it can help MSMEs, or how it can help organizations in terms of, you spoke about a lot of cost, right? So you spoke about the cost of innovation and all that. There's one cost that you also missed out, is the cost of error. Okay, so you're seeing a lot of information in terms of you can see, because of Make in India that is also happening, a lot of organizations have to build things internally in India itself, right? So one is, if they did not have the capability, they will have to build a capability. Second is, if they did not have the right product knowledge, you will have to build the right product knowledge in place. And all of this is an influx of information, influx of design development knowledge, influx of data sharing happening. So how is all that being catered in terms of, and one example that I was having with a startup founder the other day, and also a similar organization with, one entrepreneur I had, both of them were on the same lines, is where you're also looking at your manufacturing would have stayed the same because, and you might not have faced much hazards in terms of manufacturing, right? So quality and all that. But why do you feel that quality is very, very important, especially in this new era? Is also because the products that you're manufacturing now is changing at a very rapid pace. So meaning you'll also have to communicate the same manufacturing information to the guy at the downstream, if it is the manufacturing guy on the sofa. And that cannot be done alone by a regular use of those common 2D drawings that you would see. You'll have to communicate a lot of information in terms of how it should be done, what should be done. And that is where, again, like I'm talking about in terms of adopting new age technologies, in terms of model based definition, where you communicate everything in a 3D rich information, and you're also able to communicate any kind of associative changes coming in. You're able to communicate the right information to them. And if you're also working with vendors, right, so how do you share their data, yet at the same time not compromise on the IP, right? So that's the all this is where, while we're all talking about digital twin, so actual, when you're able to adopt the right digital twin, and you're basically looking at, if I were to be looking at an organization from an MSME standpoint also, right? So if you're looking at Siemens, I spoke about the main reason I brought up that slide, the last slide, where I was talking about the flexible licensing, is also from an MSME standpoint. The goal here is to give you a whole breadth of solutions and usage that you can start upon without need to worry about, uh, anybody giving you, you have to go ahead and then buy a particular set of capabilities and all that. So this whole host of capabilities will, you as an MSME, allow you to cater to any high-end capabilities that you may want to address or collaborate, or probably work on any of these, uh, because of Atmanirbhar Bharat, somebody wants to build it in-house. So if I'm an MSME, I'd be more than happy to take that in. So from a capability standpoint, do you have to worry? No, Siemens can help you there, right? So that's the whole goal that we are looking at, and happy to have a discussion with any organizations to looking at, what would be the right path, where do they want to start, right? So we also have a lot of my colleagues also working in terms of, from industry segment standpoint, helping, a lot of these startups. I as such also work with a lot of startup founders as well, to try and understand, where would be the right way to start, what would be the right approach that they would like to take, and all that.
Thanks so much, Avinash. We have a question from the audience. The
Please.
question asks, the very important question that we always ask in India, which is the cost. The question is that what is the average investment for the technology for SME and MSME, as the price is the major drive force? And also tell us a little bit about the perceived ROI or anticipated ROI that you see with the investment in digital twins.
Okay. So this is a common question that I get, and I think I more or less have the same answer every single time that comes up. See, what we always do is, especially when it comes to the cost of ownership that you're looking at, right? Is that in terms of what you're trying to do, and let's say if you're an MSME that is working on, let's say, a tooling, right? Or let's say if you're an MSME that's working on sheet metal or die design, right? So what we usually do is we can have a tailored approach in terms of the right product stack for you to start with, and then have the right approach in terms of, stacking it up one after the other, as and when your capabilities increase, as and when your business flow, business uh, vision in terms of the right approach you need from a capability standpoint is all taken care. So that is what we are looking at. And also from an ROI standpoint is something that, I'm happy to have a one-to-one discussion with you to help you to understand, to help first myself understand where do you stand, and what organization that you have, what industry segment that you're talking about. And if I can bring in my own experience, where based on my discussions and interactions that I'm having, we can have an open discussion, and then probably take the right approach forward.
Thanks, Avinash. Another question asks, another audience asks whether you would want to share the presentation with them. Would you?
Well, I can there are a couple of restricted slides. I can probably rejig and then share the shareable format in PDF file form, if that's okay.
I'd like to add to that you'll have to buy Avinash a coffee every time you get a copy of the
Oh
presentation.
yeah, I'm a coffee lover, so I'm happy to get that.
That's awesome. That's awesome. Do please remember, audience members, that you're free to browse the presentation. In the case that you have Avinash sipping coffee at the other end of the table. Avinash, I have one more question.
Please go ahead.
That digital twin suddenly, came into limelight during the pandemic, as you pointed out, and which was my experience as well. And especially, it started from the aerospace industry. I remember speaking to the stakeholders in one of the um, a, a very reputed company which is into making engines for aircrafts, and they were really able to outperform offices, their peers in other countries in terms of the way they coordinated with their head offices in the Europe and in the US. And this is how the whole digital twin, at least to my mind, in my information, came up. So my question to you is that, number one, why did it become so prominent during the pandemic? In addition to what the obvious answer is that there were restrictions, and what were the main industries that it was really able to help in India?
Okay, so from somebody coming from a business side, I can certainly tell you the kind of impact the pandemic had, and it did bring in a lot of change to us. But over the decade where I worked with a lot of customers, and lot of discussions that we've had in terms of the digital twin itself, right? Why it became more relevant during the pandemic, and why it became more successful during the pandemic also is, the answer for both of them is one, and that is, you did not have any other option, right? So let's say if I wanted to buy a bottle right now, and if I could say that, okay, acha, I'll buy it later, right? So can I survive without it? Absolutely yes, for now, right? But let's say I'm super thirsty and I'm locked out in this room, right? And uh, there's only one person who says, you want to buy this bottle or not? That time I'll still say yes, I want to buy I will say yes, I want to buy the bottle, because there's no option for me, right? And that is exactly what the pandemic brought in. There was it did not leave people with any option. And I'll tell you, the ones who became super successful, or who were able to manage the entire situation better, were the early adopters, in terms of people who are able to have smart manufacturing in place, people who had who were able to quickly adopt in terms of leveraging digital twin to be able to make any of those things that I spoke about, right? So those were the ones who were able to navigate through the pandemic in a much better way, because they were prepared, right? And the only point, like I just want to reiterate, was it did not leave option. It did not give you any option to stay the same as you were before the pandemic, right? So now you had to do it. And going forward, it will even be more relevant, I'll tell you, because now that people have seen, now that organizations have seen the benefits of digital twin, they will only start taking it forward. And now that you have one or two, in every industry, you'll have the top 2 or 3 organizations taking the advantage of digital twin. That will only make way for the entire industry to take the same path, right? If not all of them, but that would be the right way forward, right? So that is the next wave that I am personally seeing, and that will help a lot of organizations also in terms of deploying your manpower in the right way, using them in the right way, and optimize a lot of costs that are there, right? So it's not just about getting rid of the cost, but you can also optimize your existing costs, and when used, when deployed with the right digital twin in place.
Thank you so much, Avinash. That brings us to the end of our time.
Thank you.
Ladies and gentlemen, we will be sharing the information about the presentation. We'll be putting up this video on our channel, and we'll be sharing with you the coordinates of how you can reach out to Avinash for all your questions and assistance. This has been a fascinating session. I personally learned a lot, and I know that you also learned a lot of aspects, whether you are a practitioner, whether you want to know more. Please reach out to Avinash for your queries, for your usages. Uh, we will be meeting you again this week for additive manufacturing, another session which talks about digitalization. Today has been another very productive session. I thank you, Avinash. I thank you, his company, Siemens, for this opportunity.
Thank you. Thanks, everyone. You all have a good day and a great week ahead. Thank you.
You too. You too. Thank you. Thank you, folks.